Most people often refer to a black hole as a bottomless pit. Some even say that eventually everything and everyone will be sucked in by the black hole. However, others were quick to say that that's nothing but a myth. But is it really? Whether or not we will be sucked inside a black hole, it would be best to know what we would be up against. That said, what could possibly be inside a black hole? Is the black hole actually black? To answer these questions, you would have to accompany me in the journey to finding the answers. But be forewarned, we only offer a one-way ticket. Are you still here? Well, okay, let's dive right into it, or fly, or whatever. Our destination is a black hole, not in it exactly, but we'll get as close as we possibly can. That said, you should be aware of what it is. Basically, a black hole is a fascinating and mysterious phenomenon in the field of astrophysics. It is a region in space where gravity is so strong that nothing, not even light, can escape its pull. This is exactly the reason why we can't go too near, or we'd all encounter an early death by spaghettification. You'll learn more about that later as we go along our journey. That said, make sure to be on the lookout for a black hole, which is not a color black per se, but because these points in space are so dense, they create deep gravity sinks, and not even light can escape. According to NASA, a black hole is a place in space where gravity pulls so much that even light cannot get out. The gravity is so strong because matter has been squeezed into a tiny space. This can happen when a star is dying. Because no light can get out, people can't see black holes, and only space telescopes with special tools can help find black holes. These tools can see how stars that are very close to black holes act differently than other stars. So, what does a black hole look like? It was found that black holes can be big or small. Now that you know what you should be on the lookout for, you should also know just how close we can get to it. Black holes have two parts. One is the event horizon, which you can think of as the surface, though it's simply the point where the gravity gets too strong for anything to escape. And then at the center is the singularity, a point that is infinitely small and infinitely dense. That said, going near but not very close to an event horizon is still a fairly safe distance, but once we cross that area, it's a point of no return basically. As if gravity stretching and squashing objects isn't enough, another strange phenomenon that we would observe close to a black hole is something called time dilation. Time passes slower closer to the black hole than further away, which happens because of the strong gravitational fields that curve and stretch the fabric of space-time. We do actually experience time dilation on Earth, but in a very small amount because of Earth's gravity. This has been seen on airplanes, where clocks tick at slightly faster rates in the air as opposed to on the ground. To imagine time dilation in action, picture an object traveling towards a black hole. As the object approaches the event horizon, it appears to start moving infinitely slower until the object will appear completely frozen. Here's what's more terrifying. Black holes can grow more massive over time as they eat gas, stars, planets, and even other black holes. Yes, other black holes. There are actually 4 types of black holes: stellar, intermediate, supermassive, and primordial. The most commonly known way a black hole forms is by stellar death. Let's get closer to stellar black holes that are made when the center of a very big star falls in upon itself or collapses. When this happens, it causes a supernova, which is an exploding star that blasts part of the star into space. Now, let's fly forward, but not into, supermassive black holes. Almost every large galaxy, including our Milky Way, has a supermassive black hole at its center. The one at the center of our galaxy, Sagittarius A, is 4 million times the mass of the Sun. Then there's the intermediate black holes. Scientists are puzzled by the size gap between stellar mass and supermassive black holes. Our last stop, primordial black holes. Scientists theorize that primordial black holes formed in the first second after the birth of the universe, although scientists are yet to find definitive proof these ever existed. It's possible, however, that they could have evaporated as the cosmos aged due to quantum mechanical processes occurring at the edges of their event horizons. That is what we don't want to happen to us, evaporate. So let's get out of here and continue our journey in a much safer distance. Regardless of their starting size, black holes can grow throughout their lives, slurping gas and dust from any objects that creep too close. Anything that passes the event horizon is in theory destined for spaghettification. Spaghettification. It is quite an odd and funny word, but its meaning is nothing of the sort. Anything that ventures too close to a black hole will be stretched and compressed like putty in a theoretical process aptly known as spaghettification. Not so funny now, is it? Especially if we imagine that happening to us. Although we couldn't and shouldn't get too near a black hole to know what's inside it, we can still guess and rely on already existing data. Unfortunately, the answer to that is no one knows. No one would dare try and end up being spaghettified. Still, there are several possibilities of what could be inside, or at least on the other side of a black hole. First, the planets and stars sucked inside a black hole could remain as they are. Or, two, these can be broken into smaller molecular pieces due to the immense gravitational force. But there's also a possibility of a white hole. White holes are theoretical cosmic regions that function in the opposite way to black holes. Physicists describe a white hole as a black hole's time reversal. While a black hole's event horizon is a sphere of no return, a white hole's event horizon is a boundary of no admission. According to James Bardeen, a black hole pioneer and professor emeritus at the University of Washington, somehow it's more disturbing to have a singularity in the past that can affect everything in the outside world. What physicists today call a singularity is a spherical mass shrunken down to an infinitely dense point, wrapping space around it so tightly that the region pinches off from the rest of the universe. It forms a no man's land whose event horizon fractures the link between cause and effect. Black holes, the most famous singularities, are regions of space so warped that no exits exist. The outside universe can influence the inside of a black hole's horizon, but the interior can't affect the exterior. White holes are believed to be the other side of the coin, the exact opposite of a black hole. Even armed with this knowledge, I bet you still wouldn't want to be on that side of things, especially after hearing this. It was very recently revealed by scientists that the exact speed of black holes zooming around the universe is faster and more destructive than first thought. Basically, scientists found that black holes can move just under 10% the speed of light, which proved there is much more to learn about the mysterious energy voids. If you aren't too daring to risk being close to a black hole, you can opt to travel to our cosmic neighbors instead. Watch this.